Welcome everybody to another edition of KAUST Live. For those of you that are watching on Facebook, we have a packed house, so you might have a better seat at your computer right now. For the people that are in the way back, I have a suggestion. Up on the next floor of the library, the third floor of the library, there's a balcony. You can look down, you can watch the proceedings maybe a little bit better. I think that saves an introduction to the topic. I could have said AI related to donuts. I could have said AI related to laundry detergent, and I think we would have had an incredible turnout in the crowd. It's clearly a hot topic. But just to remind you of the format of how the Sci-Café works, we're going to ask the panelists to introduce themselves here briefly, talk about how they came to work in the field of AI and what their research looks like. And then I'll ask a few questions. The idea is to try and put them into boxes to make it clear to you what the expertise is of each of the panelists, because after about 15 minutes, I'm turning this over to you. And with such a large audience, I expect you to be ready to ask questions. We should be able to ask questions, really get to some interesting topics in AI through the course of the Sci-Café today. So with that, I'll let each of the panelists, starting with Zhang Liang, introduce themselves and say a little bit again about how you came to this field of research.
Okay, good afternoon, everyone. Thank you for coming. My name is Xiangliang. I'm Associate Professor of Computer Science here at KAUST. I started my first AI problem 16 years ago when I was doing my undergraduate thesis. The problem I worked on is to find out who is using the computer based on how you are typing the keyboard. Is it me or someone who stole my password? So this is the problem I started. And then I worked on different type of AI problems. So my main research interest is to find the most interesting patterns from the complicated, large-scale, streaming, temporal, very complicated data set. So for example, we study the human trajectory from your mobile phone, for example, try to recommend some place you want to go and recommend friends you want to meet. And we study animal trajectories, trying to find the animals who are friends with each other or they are having some special relationships. And I also work on scholarly data and trying to recommend the research papers for you to read, for you to cite. So I work on different type of data. So this is my research area. Thank you.
Yeah. Marco, you want to say a little bit?
All right. Hi, everyone. I'm really excited to be here. What a crowd. So I'm Marco Canini. I'm a faculty in computer science here at KAUST. I build, study, evaluate distributed systems. These are software systems that run across heterogeneous collections of thousands of machines deployed all over the globe. And some of these machines, require to solving very complex problem. And that's one of the reasons for which we have turned to AI as kind of like an aid to solve this problem. But also, as you know, AI is very compute intensive. In particular, machine learning, data-driven approaches requires hundreds of GPUs, terabytes of disks, and so on. And so there is subtle efficiency questions that we must solve, and that's part of the work that we are trying to do in speeding up AI. Additionally, we also work on questions related to how to make AI reliable and more robust. Who would want to, ride on a self-driving car if that car is going to crash you into the wall, right? But, this technology is still very immature, and we don't really have a good, sound understanding of how it really works and whether it's always going to be reliable for you. Now, going back to the past, I started working with machine learning during my PhD. Back then, one of the problem we were trying to solve was having a look at traffic on computer networks and trying to understand what kind of applications were creating that traffic. Say, was it voice over IP? Was it HTTP traffic, and so on? And for that reason, we built a complex classifier that could accurately pinpoint sources of traffic.
Very cool. The next person doesn't need much of an introduction, but I will say this. He's here today in his capacity as a professor, and actually with a little bit of a background in this field. So, Tony, why don't you go ahead and give some of the history.
Yeah. I'm glad to have this opportunity to introduce myself as what I used to do. Okay, that is in my own personal research. I to be honest, I've not been active in research since I became a university president 9 years ago, basically 9.5 years ago. But my contact with AI has been, on a research point, is I was interested in imaging. I was doing imaging work. You can imagine medical imaging, extracting features from, images, extracting like how to detect a moving car in a video, sort of the standard image processing. It relates a bit to computer vision. Okay, so those computer vision is to take images and create a 3D world. So you see, so that's how it's connected. The big advances in AI really started less than 10 years ago. And a lot of the advances are based on image-based application, like face recognition. So I was sort of trying to follow it based on what I know. I also have another hat, okay? I have been writing for the last 5 years a weekly column on general things, okay? Things related to technology, higher education, global events. And this is weekly, okay? And as you can imagine, in the last few years, one of the hot topic is AI. So I've written quite a number of articles, popular, not technical, on AI, which has forced me to look into both some technical aspects, but also some philosophical aspects. Many people, and I come in contact with many people from outside of science and technology. They don't know what this is. They either think they can solve the whole world's problem, or they think they would take their jobs and sell their soul to AI. So I think maybe we have time, we can talk a little bit about that.
Yeah.
Another aspect last aspect I can say is, because I was a student of computer science. I did my PhD in computer science long time ago, okay? And one of my first courses I took was in AI. This is 40-some years ago, okay? And the AI then was very different from AI now. So I look at this, and I have sort of lived through what is referred to as the AI winter. If you are interested in that, I can tell you a little bit more about that. I think I mention that because I think there's a lot of hype about AI today. By the way, a lot of it is real, but there's also a lot of hype. So having a historical sense, I think is healthy.
Yeah.
So maybe I stop there.
Good. What I'm going to try and pick up on, if you don't mind, each of you, I think, has a different contact point with AI. Like, I was interested to hear that you started in AI 16 years ago, but yet now you're applying it to different domains. So maybe you can talk about how in the last couple of years, how is AI getting applied to what you said, which is sometimes it's typing, sometimes it's networks, sometimes it's even animal noises. I mean, how do you apply it to so many different domains?
Okay, so the common thing in different domains, in different applications, is the data.
Yeah.
So data is the representation of the problem. It's a describe your problem. For example, in order to find who is typing, we need the data. What is the data? Data is how people are typing, the strength, the interval between when you type the keys. And when I work on animals or human trajectory, what is the data? The data show me where and when people visit different places or animals visit different places. Yeah. Or when I work on social networks, I work on scholarly data. All of these are about the data. So data is the core. Data connects the techniques in AI, in machine learning, and different problems. So this is, I think, very important.
And what about, because I think most of the people in this audience are coming from different fields, even some non-scientists, but I think some of them want to now come into AI. And so what about people who want to do the reverse of what you did? Do you think that's possible? How could they go about learning and starting to apply AI to their field of research?
You are very lucky now, because in this period, AI is very hot, and there are a lot of open resources for you to use. Even you're out of computer science. So for example, if you know Python and there is Scikit, it's a very easy to use toolbox. There are many functions available there. So what you should give is the data, describing your problem, and then the function can just take the data, give you the output, give you some prediction. It's very easy. The code may be only a few lines or less than hundreds of lines. It's very, very easy for you to use. So as I said, this is a very good period for everybody to join this community, use AI, machine learning technique on different problems. We are happy to see how AI can help you. We should be very proud of AI and proud about how AI can help you.
So let me take your comment to the extreme, to you, Tony. So do you think we're going to be at a point soon where AI should be considered, that computer background should be considered for all fields in some way, shape, or form?
Yeah, if you take the point of view about it is based on data, then any subject you have data, you can apply. The mathematical basis is very similar. When you apply the data, of course, are different. But I do want to comment on that. That is the current approach to AI, which has this big success, is based on data. It's not the only way. In fact, this was not the way I learned 40-some years ago, and I'm sure it will be different, 40 years in the future. But the current approach is actually, to me, is like a perfect storm that makes it work. What is a perfect storm? The perfect storm is, first of all, you have very cheap and universally available data collection devices, like your cell phone, right? It's so cheap to do this. You also have available hardware that are fast enough, powerful enough, okay? And then finally, some very clever researchers have come up with very interesting models, okay? You heard about these neural network, deep learning, convolution neural network, all this, okay? So somehow each one of this by itself is not enough. So some of these ideas, neural network goes back decades, okay? But when you have a perfect storm, then everything works together, and there's the killer app, like face recognition, and all of a sudden, then you see the result. Then next thing you know is AlphaGo, beat the best human. And then in fact, AlphaGo 0 does not even need data, okay? So people see this, and they think, wow, this is the way of the future. But I suspect that this is not the only way to do AI. See, based on data is this, right? It's like a baby learning about the world. So in a way, it's a human learning. Yeah. The baby is observing, right? It's collecting a lot of data, and is picking up things as we go. But are we at the level of Einstein? Are we at the level of Picasso? That's a different kind of creativity and so on. I don't think the current AI is at that level. And we may require other approaches. For example, more like a human neural approach could be other approaches. So I do want to caution about that. In fact, even with the current approach, people are discovering that many of the AI algorithms do not work in other domains, okay? But yet, the whole civilization is now making a big turn, a big pivot. Our medical diagnosis, everything is counting on that. So there's a lot of worry about how to govern AI. I can tell you the politicians, the government are already worried. They want to make sure they set the rules of the game so that this thing is not going to go crazy. Okay, so that's
Let me switch gears a little bit. Marco, you spent some time in industry. And especially in this field right now, there's a lot of even joint appointments. People are in academia and in industry. So how come there's such a good crossover in this field, and is it necessary even in some cases?
Well, so this ties very much to what Tony is saying regarding to the data, right? So we have a lot of data collection devices, that's true, but the very large data sets actually, they end up being with very large companies. So it is very attractive, to have basically 1 foot in academia and 1 foot in industry, where contractually, you basically have a legal framework to be looking at the data and messing with it. But I would also, caution in general that the data-driven approach is one, but just one approach to actually go about creating AI, and it's definitely not the only one. And it is one that we need to be careful because garbage in, garbage out. You might have heard of this, right? So if your data is telling a story that is biased or contains the wrong story, then the algorithms don't really have real intelligence, right? They're just basically going to make false predictions. So we need to be careful. And in fact, I would say the technology is still, fairly immature, despite all the leaps that have happened, during the past, say, decade. It is still pretty easy to, say, fool a neural network in doing a misclassification. We were just reviewing papers this week that were showing that how, simply by changing the level of brightness of an image, you could make a classifier completely misclassify the prediction. So this means that the technology is still not really there, and that's why we need to continue having a lot of research. And one of the things that I also wanted to mention is that if you are curious to join into the community at KAUST, you have now a new initiative. It's called the Machine Learning Hub, which is ml.kaust.edu.sa. And anyone is really just welcome to come and join the community, hang around, ask questions, get in touch with people with more expertise, and get bootstrapped with the various techniques.
Very good. I'm going to get out of the way because I'm sure we're going to have questions for a while. So please, what questions do you have from the audience? Oh, come on. You can't fill the room like that and not ask a question. I'm told you need to hold this close to you so you can be heard. Terove?
Thanks. I'm hoping I'm holding it close enough for the system. One of the things that you talked about, which intrigued me a little bit, is this ethical aspect of the research. And we have this in every field and everything. How do we mix the ethics with the science? And in terms of the AI and the ethics, I'm just curious on where is this going and how is this happening? Because you hear stories like the lady who got fined for jaywalking because her face was on an ad on a bus that drove past. And that picked it up, and she was defined as jaywalking by the algorithms and got a fine, even though she wasn't even in that city. And so, there's a lot of potential in it, but this aspect of data security, personal security, and the ethics, I'm just curious on where that is headed.
Tony, you want to start with that one?
Yeah, I was, a week ago, I was invited to participate in a meeting in Dubai called the AI Governance Summit. So people there, they're, I would say maybe 10-15% are technical people. The rest are politicians, humanists, social scientists, psychologists, business people. So everybody has a stake. So the short answer is, I don't think people know. They just know or they fear there's a problem. So ethical problem can be manifold. For example, you're going to trust an AI doctor to diagnose you? Okay, do you trust your data, personal data, that's going to be used? There are a lot of recent scandals. There are also legal issues. Who owns the data? If the computer makes a mistake, who's responsible? There are many, many of these things. Who should regulate? I made the point, actually, at this meeting, that coming from a university research sector, we have to be, as a society, we have to be very careful to balance between fostering innovation and over-regulating, right? So, because my fear is this, most of the people doing this do not really understand the technical basis of AI. What is real capability, what is limitation, what is power are. All they see are the examples, right? You can beat the best human in Go, it can do many, many things. So they just say, wow, this is coming at me. We better talk to the politician and make sure everything is okay. And it can over-regulate, and therefore suffocates innovation. That's what I worry about.
You guys want to add to that at all? Inherent bias?
Yeah, I mean, that's a concern, right? So there are several episodes nowadays of failures of AI. One of the epic failures has been this Microsoft chatbot named Thai, T-A-Y, which was released on the internet, and it was in principle it was a good idea. You could send tweets and then engage with a conversation with an AI that was going to pretend to be a 19-year girl. But the truth is that people could actually bias entirely this AI by just sending a lot of, well, let's say, the worst representative of humankind.
The internet.
The
yes.
internet. Yeah. Quickly the AI changed completely the parameters, the training, right? So that is an inherent limitation of this technology as it exists today. And very quickly, Microsoft had to switch off this experiment because they just basically created some kind of like racist AI. So it's a very dangerous.
I encourage you on your free time, if you want to see the interesting story, go look up the chatbot. I learned from Marco the other day, and
right. And this is one example, right? That there's many of these things that are documented and reported, and so we need to be careful overall in terms of both the ethics and all these algorithmic biases, because indeed it's really not clear from a lot of perspectives, including the legal perspective, what's going to happen once the technology gets broadly deployed and adopted, and people's basically lives are at stakes in a sense.
What other questions are out there? Yeah, Matt.
Thanks, John. Tony, this goes to your point a little while ago. This is not the first time that AI has been a hot topic. Mm-hmm. So I'm curious as to what's different now to stop it from fizzling out like it has before.
That's a good question. I've been thinking about this, okay? The first AI winter, some people claim there are 2 AI winters, they actually make plots, was overpromise. Okay, in the old days, the computer can beat people in checker. That was relatively easy. Then they beat people in chess, you remember, right? But in a way, the algorithm, they were very brute force, frankly. But people extrapolate from there and say, now we can do all kinds of things. So there are approaches that did not measure up to the promise. There was a system, for example, I remember one called expert systems. I mean, they're actually companies formed there, which basically they interview experts. Let's say you are oil extraction expert. So they interview them, try to extract their knowledge, then code it up and try to do it. It turns out that was the wrong approach. But the promise is out there. The hype is out there. So after a while, the business part is not going to invest because they don't see the result. Even the research funding agency was sort of backing out. So for example, in the early days, in the US at least, the only funding agency that funds AI was DARPA. Many of you know DARPA. Then after the AI winter, DARPA go to 0. DARPA basically does not fund, so because they sort of gave up. Then more recently, there was a DARPA challenge with the robotics and all that. There's a little bit of that. So I think that's a lesson there, okay, to be learned. If you hype it too much and the technology does not catch up, people lose confidence, and you only have one chance, so to speak, at that. But on the other hand, the current advance is real. Because of this perfect storm I'm referring to. And in addition, there are these tools that you're referring to. Now, anybody can go online and use TensorFlow. Python, was that the other one? And so the Googles of the world actually want to make it available. So you don't have to be a technical expert. You can do this. And the technique is powerful enough in many cases to actually produce good results. So most of the business world is already trying to brace itself for this disruption. So there was a survey, the reason I was referred to, I'm not a, it's called the Edelman Report. I mean, you can go online and check it out. So they interviewed the CEOs of the world. What do you think? Is this AI thing going to disrupt your business? So they tracked this over the last few years. Anyway, the number I remember this year was 60% of the CEO think this would disrupt their world. So they're making plans. Okay, I don't know, acquiring system, changing the way to do business, right, and retraining people and all that. So you probably will see this already, I think, in our world. You know, even here, you can talk to your phone. You know, you can sort of look at biometrics. You know, you can look at your face and be able to let you in, and so on. So that is coming for sure. So I don't want to belittle that, okay? But I think the philosophical approach for us is there a basis for that optimism? Is this a universal technique that can be applied to everything? Do we really understand why it works well? There's very little theory on this.
Well, let me take that opportunity then to ask each of you. I mean, my personal opinion looking from the outside is it's still quite a bit of brute force. With enough parameters, you can fit a curve to any series of data. But I'm a chemist saying that about your world. So where do you think the next 5 years, where's the big leap potentially going to happen? Marco?
Right, so one thing that we have seen is this perfect storm that Tony was saying, right? So in a sense is what is going to be the next perfect storm. Hardware is getting better, right? Over the past half a decade, GPUs have gotten basically 30 times faster. And nowadays, the data is also growing at an exponential pace such that we can actually start to build ever more complicated models. And what more models, what it means is that you have more parameters, which means that you have richer representations, more complex functions that you can represent. Now, one of the things, though, that it's becoming clear is that there are areas of application where these techniques are not perfectly suited. So one thing that the research community is now starting to realize is that it is perhaps appropriate to now take a step back and retrace some of the steps so that we're not really just overhyping and thinking that, given basically this big hammer, now every problem is a nail for that hammer. But rather, what should be the next set of algorithms, the next set of structures for neural networks, or the next set of hardware architectures as well, which may no longer be power-hungry GPUs or even these tensor processing units created by Google to accelerate their machine learning training. That are much more power efficient, but yet confined to matrix multiplications as operations, essentially. So all of these, we, in a sense, we need to invest in all of this direction and have a multi-pronged strategy, because any of this could lead to, a new perfect storm.
So I want to add something to what Tony and Mark mentioned. So. As I said, many AI application domains now they use data as the center, as the core. And as you mentioned, data cannot be, cannot solve all the problem. And I remember that when I was teaching machine learning in this semester, in the first class, I listed out many successful application domains to the students. AI was very successful on this long list, but there is another list. AI is now doing very well. A very important feature that is missing for the current AI is it has no common sense. What is common sense? So, for example, if a machine is asked, who is taller, Prince William or his son? Of course, we will answer the question very quickly, but the machine may not be able to answer it because it has no common sense about the relationship of father and son. And if you ask a robot in your home to say, give me a glass of water, even my 5-year-old son will say, if the glass is not clean, I want to wash it at first, and then I give you a glass of water. But the robot will not do it. It will just give you a glass of water. So this means AI is missing common sense now. So where can we get a common sense? So we have to use some knowledge from us, from our human. And so I want to mention 2 examples that is quite successful already. So in this area, people are trying to push the limits. And I'm not sure if in 5 years, and we will get some common sense for AI. So I want to mention in computer vision field, there are deep learning models learned from millions of, or even more than that, images. And a huge amount of images were used to train a very deep, very huge network. And this deep network will be the base for a lot of computer vision application problems, for recognizing face or digital letters or different things. And in NLP, in natural language processing, very recently, a few months ago, there is another model, it's called BERT. And this model is also deep network. It is trained on huge amount of articles, papers, for example, from Wikipedia. And this model has already been shown to be very successful on translation, machine translation, translate from one language to another, and on many other NLP applications. That is saying these deep models learned from this huge amount of data, they are having some common sense. Very, very weak common sense. But they are having some common sense. But of course, we should not only let the data to introduce common sense, we should have something else to enhance the common sense for AI models.
Do you want to add anything, Tony?
Yeah. You know, in a way, the traditional approach, right, to AI is to imitate human. Okay, how, you know, do chess, you know, I make this move, the opponent make this move, right? In fact, neural network is a way of imitating human, right? It's a neural network, human neural network. But I would say the current approach based on the big data, it doesn't go all the way, okay? So I think for the future, I think it will have to use that. I think you still need data. Human, we do data, right? Each one of us carrying with us our history and experience. But I think we need a little bit more of the human side, the psychology side, maybe the deeper neural. Actually, we don't understand how the brain works. This is my understanding, the state of the art. So, but I think we have to think about how humans work, because the human, at least so far, has a way to grow beyond like a baby or a little kid. Somehow, we have people like Einstein and Picasso. How do they come about, right? So I think we need a little bit of that to extrapolate. I think, maybe I say one more thing. So, as you know, if you went to our town hall meeting, one of the things we're trying to do at KAUST, where I'm thinking about, is make a big push in AI, machine learning, and so on. In fact, I charge a group of faculty. Are you on it? You are on it, okay. So to map out what we should do, okay. So in fact, one of the questions of what is the thing of the future? Because if we don't want to do things that are in the past, okay. And what is it that KAUST is in the best position to do? Because we're not just any university. We're not big, right? But we have an interesting funding model. We have our advantages and disadvantages. So in the process of this, there are things that comes out. Like hardware is a big trend. But I think hardware, there's still a limitation, right? It's still based on the current model. You just make it faster. So that will keep us going for a little while. But the fundamental model, if it doesn't change, then there's still a limit. You'll hit the limit a bit later on. Are there other applications? I think that's, as you mentioned, the application is actually quite wide. In some sense, anywhere you have data, you can potentially apply, right? But is it going to be effective? I think that's the question. So if you look around, there are many things that can be applied. Now, most of the things that the big companies are looking at are things that are commercializable, right? First of all, you have data. You have commerce data. You can monetize it. You can make money out of it. But maybe there are other things. For example, at KAUST, we do science and technology. Can we use AI machine learning to help us do better science and engineering? I think that will ultimately it will be beneficial to humankind. But so is that something that we should do? I think in a way. I'm waiting for the report, by the way, from the committee. But if you have some suggestion, you should feed it to them. But I think the field is debating. I mean, the people in the field is really debating about this. Okay.
What other questions are out there? I'm not going to throw it that far. Go ahead, Caroline. There's way back there. Way back there.
Thank you for that. I have a question. What about jobs? Will we reach a point where governments need to introduce basic national income to people because the flow of jobs is not enough for what we have? And with that, there is another issue. Jobs is a motive to wake up in the morning. If it's been taken over by machines or whatever it is, how would we motivate people if that's the case?
All right, get outside your comfort zone. Go.
Thank you. This is the biggest concern, as I mentioned. You know, people call now we are in the fourth industrial revolution. So if you look at the first three, which is what? Steam engine,
Electricity.
electricity, and computing.
Yeah.
You know, I've lived through only one of them, so to speak. But you can, it's all around us. Certainly, you know, the invention of the steam engine has changed the job scene. The invention of electricity, even the light bulb. Even there was a famous case, I remember someone said, if I were making candles, right, 150 years ago, I would be out of business. But those people are doing something else. I don't think this one is going to be any different. It will require people learning about the new thing. There will be new demand. I think ultimately we still need the human interaction. There will be that kind of thing. Do people trust? So you maybe, I'll give you two examples, okay? Just last week, I come across two papers, articles. One written by lawyers, okay? In fact, I can tell you, it was a Columbia Law School, okay? I was visiting Columbia. There was a little brochure. It says, you must be wondering whether we still need lawyers, okay? Because a lot of lawyers is what they call discovery, right? You go to the library, you check out things, you look at cases, and everybody thinks, you know, you can do it by computer, even better. But their argument is, you will always need lawyer. Our job will be different, but you need us because you need the human interaction, okay? If you go to a lawsuit or trial, would you want a computer to do it for you, or would you want a human to do it for you using computer to help him? So that was their argument. The other article I read was written by a radiologist. So there's a radiologist, actually a big data-based profession, right? Human look at a lot of thousands, tens of thousands of images, and based on their expert knowledge, they will render a diagnosis. Well, computer can look at tens and thousands of millions of images. So the radiologists are saying, should we worry? And the answer is the same as the lawyers. Our job will change, but our job will still be there, okay? But I think they would say you have to also adapt to it. So the radiologists and the lawyers will have to know what AI is, okay? How do they adapt it to their profession? How do they adapt to their customers, clients or patients' needs and concern? I think that's my thinking, okay? I can't predict the future.
But just to probe the question further, I think the challenge, you said electricity, say that's the second industrial revolution. There's still parts of the world that don't have electricity. So
Yeah,
that
that's
time
true.
frame is 50, 100 years, right? But the time frame of this fourth
it's
industrial
faster,
revolution
much faster.
could be 5 years. So how am I going to retrain as a 50-year-old employed candle maker in the time frame of this industrial revolution?
I can't predict what people are going to do.
Yeah.
But, so government has a role,
Yeah.
for sure, you know, to retrain. So there will be disruption because these changes are fast in time. I'm thinking about a little longer in time. Society will adjust. But in the meantime, there will be real disruption. Lives will be disrupted, that's for sure.
Marco, do you want to add something?
Yeah, I mean, I can add something. So everybody knows that, you know, the famous way to reason about exponential growth, right? We take a lot of people in a stadium and then drop exponentially increasing number of water drops, and, you know, when is it that people realize that they're going to be completely flooded, right? When they will see that the stadium is like half filled with water, they don't realize that, you know, the next time, that's basically when the water is going to get to them. So that's to say that indeed things are getting exponentially faster, but the human mind is not really built to deal with the exponential. Now, one thing that I know is that exponential growth in a finite resource world doesn't really work. And so we need to be indeed a little bit careful about what kind of progress we will be enabling with AI and what kind of impact in terms of job displacement it will create. Now, on the one hand, and as a little bit of a joke, when you have weather like this, I wouldn't mind having 3 hours of work per day and enjoy the weather instead of having to work 12 hours. But jokes aside, it is true that there is going to be different sectors of society impacted at different times, and there will be, in a sense, very little time to react. One big concern is, that society, especially in the West, is still, kind of like struggling to value more than GDP and other kind of key economic growth type of indicators. So we need to account somehow for quality of life as we think how to integrate AI. Everybody realizes that, for instance, self-driving cars is a great idea in principle, right? But how do you contrast, the millions of dollars of investments in developing that kind of technology, which, ultimately is still unproven and has cost some human lives, versus Uber and similar companies that, can still essentially provide a source of income through the sharing economy, right? And which one is actually going to work as a race to the bottom, right? Is the human labor cheaper, or is it going to be the AI and the costs and the sensors to equip your cars going to be cheaper? So all these considerations, I don't think that there is any final answers, but they need to be accounted somehow.
Any other questions? Yeah.
Many services today in the internet, they offer recommended systems, like, for example, YouTube or Goodreads. And I noticed that many times when, for example, you watch something on YouTube, YouTube starts to offer you the same kind of stuff immediately, and it feels like
Big Brother's
forcefully
watching.
watch something, and then it offers you only these kind of things. So my question is it intrinsic thing for neural networks that you add something new to the input and then the output changes drastically, or it's just artificially tuned to, to make more profit?
Not artificially. Yeah. So, because I work on recommendation systems, we recommend movies, we recommend papers, we recommend a friend, we recommend interesting places for you to visit. So there are two kinds of recommendations. One is personalized, like what you said. You click on one video and then similar things will be recommended because the system learns your interest, learns your preference. That's why the similar movies will be, or videos will be recommended. And the other type of recommendation is not personalized. So that will just recommend the most popular movies, most popular videos, most popular papers. And in this case, you may not feel like if you click on something and you will have similar. So all of these are based on some models. I would like to see AI models or machine learning models. And it's continuously learning your behavior. Learning, not your behavior, like your interaction with the products, the movies, the videos, and then trying to give you better recommendation. So I would like to see recommendation system makes our life easier because search engine helps you find something you want. But you have to tell the system, tell the search engine where you want. You have to give the keywords. But in recommendation system, you don't have to tell what you want, and they will guess what you like, and they give you something.
No, they will guess what you'll buy.
Yes.
That's the difference.
Yes. So this is the difference between the recommendation and the search engine. So I think its recommendation system is more, let's see, intelligent in some cases.
Tony?
So how many of you have Netflix at home? Okay. I never watched Netflix until I came to KAUST. Okay. So, but I knew about Netflix because Netflix had a Netflix challenge 10 years ago or something, $1 million back then. and the executive is to design a recommendation system.
Yeah.
That one I understand quite well. It's actually quite mathematical. So basically, I don't know which category it falls into. Based on what you have watched,
It's personal.
based on what other people, that's the big
Yeah.
data part, what a lot of people have watched,
Yeah.
there's some similarity overlap. And so based on what other people are, will overlap with you and what they watch, they can recommend that to you. It's actually very logical. Okay, that probably if you have a human, you would do the same thing, but the computer can make it more systematic. And there's a whole mathematical theory. Many people do that. So I like it actually. If you understand what its limitation and powers are, it's just another tool that you have. So try it sometime, right? It's not a recommend. In fact, it tells you. If I understand, right, is it because you have watched this show, therefore it's recommending this to you. But behind it is some matrix, some optimization. It's not that deep, actually. You agree?
Yeah.
Okay.
Tony, sponsored by Netflix.
No, they're probably onto something now. This is 10 years ago. The new version should be $10 million. So,
What other questions are out there? We got a few more minutes. Yeah, there's one back there, Carolyn. Or I'll try and
Can we
throw.
turn this mic on, please?
It's good. You got it.
Well, the AI is like ocean. The possibilities are endless. So I want to know in what type of areas KAUST will be particularly focusing on AI, because it's huge, right? in what type of area KAUST will be focusing on researching and developing.
How about if I reframe this and I ask each of them what areas would they suggest or recommend?
That's a great way to answer that. So there is indeed an AI committee. Tony was referring to it before, of myself and Xiangliang are within that, and there is 10 more faculty members, and this is one of the questions actually that we are analyzing and studying. There's actually going to be a report written soon. Actually, it's already written, so we're just
73
doing
pages
the
so
final,
far, by the way.
The final edits. Already 70 plus
Already
pages.
70
yes.
plus, yeah.
But ultimately the question is, where do you folks think, right? We could look into applying AI in a way that becomes a great strength to KAUST, a great differentiator, right? Obviously, one could say, let's go and pursue the things that others are doing, like let's build another self-driving car, let's create the greatest recommendation technology and so on, but we may be a little bit late to that kind of game, right? So here, the opportunity exists, but we need to really focus on what are going to be the next few big things so that we could actually shine on those and be early to the game.
Mm-hmm. What's your take? What do you think is something where we can be early to the game?
Wow. So I think because we are on a committee and we had a lot of discussion about what will make us unique, make ourselves unique in AI. And I think we talk about the AI in medicine and in Arabic language processing. This is also quite unique. And also, let's see, we are right next to Red Sea, and if we study some very special data from Red Sea, and this is our uniqueness.
So you're essentially framing it around unique data sets to KAUST or to the region.
Yes, I think in the report we have something called the unique data set we can provide, I think, because it's quite important.
And Arabic language processing.
The Arabic language processing.
Is this not necessarily a well-studied field in machine learning?
So as far as I know, there are a few teams in the world, they are doing very, very good about natural language processing. One of them is Google. But I think in this region, we really need, I think KAUST is leading the research in this region, and we really need some research team here to work on this topic. I think it will be very exciting.
Additionally, I would say it's something regarding scientific discovery, right? So what Tony was saying before, we are strong in science and technology, so can AI really supplement the production of new discoveries related to the topics that we're really already strong in, whether it is the Red Sea research or the combustion center. Nowadays, we're helping McLaren, win the Formula One championship that's going to start in a couple of weeks only. So let's see how.
You're guaranteeing a win? Is that what you're saying?
Well, maybe
AI is that powerful, that fast.
Maybe we should look into that. That's what I'm saying.
Maybe I can come, because I charge the committee, right? So my thinking First of all, why do we even want to do this, right? So we have some faculty members here already. I think my thinking is, if I look at the last 10 years, okay, you look at what is the biggest trend in tech that has the most impact, I think you have to include AI and machine learning. There has to be one of them, if not the most, okay? So we as a University of Science and Technology, in a country that is trying to sort of move beyond oil and go into innovation and technology, I don't think it's an option for us to say, we opt out of this, okay? So but given that, we are very small. In a way, we don't have the big critical mass yet, okay? So we have to be strategic as to what we want to do. So I think my charge to the committee was, given that we have some strengths, please take into account the special nature of KAUST and where we are, given that we probably don't want to be just me too, and actually coming in late. How can we make a mark and make a contribution? So what are some of the things that we could? So one of the things mentioned is we are a science and technology place. We generate a lot of data in our lab, in our computer, right? We actually generate a lot. We have a lot of need. And this is one area that the commercial companies are not interested in now, okay? They may. If they discover there's a big market here, they will, okay? But that's one area we can do. Another area I mentioned also a little bit earlier, that is our funding model is actually quite steady, sustainable, long-term. There are very few places like this, okay? I'm used to the US system, okay? I used to have a group of 10 people. Every year I have to have 4 grants active. And every year I have to renew at least 1 or 2. So, okay, so you have to do this. We have sustained fund. So perhaps we can, first of all, have a more sustained effort. We don't need immediate, result. So theory is one of those, okay? We can take a little bit more risk, okay? So I don't have to write a proposal every 6 months. And so I can't afford to take the risk. So that's another thing we do. Another thing, you look at where we are in a place where we have some large technological companies, like Saudi Aramco is one, then there are several others. We probably don't have other big industry. If you look at the demand, at least locally, that may drive some of our development. For example, I've been talking to people, outside. So, and going back to Xiangliang's point, that is, the fundamental algorithm and model can be applied to many areas. So, for example, let's look at the oil industry. A lot of industrial plants and processes, they have a lot of data. So can we apply machine learning to make that process more efficient? I think if we make Aramco's process even 1% better, there's a lot of money there, right? I don't think the Googles and Amazon of the world are looking at those problems yet, okay? But they may soon, okay? So anyway, I just give some example. I hope the committee has looked into this. And there are many other examples. Another one I mentioned is quantum computing. Many of you look at this. So quantum computing could be the hardware, if you will, for doing this. It itself may be more amenable to AI-type application because of quantum. But is it ready for this? By the way, there are companies producing these computers, but I don't know enough. The committee probably will address it. Maybe it's a little premature for us, right? So I don't know. So that's the thinking. But nobody has the crystal ball. So we have to take some risk.
I think, I know there's probably a million more questions out there. I'm sure the panelists will stick around a little bit, but I'd like to maybe cut it off on that anticipatory cliffhanger. Hopefully the next time we get together and talk about AI, we would have some answers about how can KAUST try and really make a mark in this field. So thank you for coming. Thank you for the questions. Please join us next time, and please join me in thanking the panelists.